Now we're going to look at higher ordered polynomials. And so here, once again, we just kind of have some guidelines like find this information, and basically that should help you graph your function. So we'll do the leading coefficient test first. And so basically, you look at the first term because he's the one who's going to be the largest number as x goes to infinity or negative infinity, right? All those other numbers, they may be large, but this guy's going to be the largest, so he's going to determine whether the graph goes up or down as you go to positive infinity and negative infinity. So if you plug in positive infinity and raise it to a third power, you're going to get positive infinity in return, okay? So you're going to get other numbers, but in the long run, this guy's going to take you up, okay? If you plug in negative infinity, negative value to the third power actually results in a negative. So you're going to end up at negative infinity. So what that basically tells us is our graph is going to go up to the right and down to the left. So I went ahead and put some little markers up there, okay? So when we graph it, we'll have to remember that. But now it's time to figure out, well, what happens in the middle? Well, we might go up and down and cross the x-axis a few times, and so that's what we're going to look at next, is finding the x-intercepts, and then we have to think about their multiplicity of whether, you know, it crosses the axis, and sometimes it just kind of dips down and touches it and goes back the same direction it came from. So we'll look at that as we do that. So scroll down so I have plenty of room. All right, so we'll start by finding the x-intercept. So this one in particular, I can do factor by grouping. So I'm going to factor out, I'm going to start by factoring out that x squared right there. And that'll leave me with an x minus 1. And then here I'm going to factor out a negative 9, and that'll leave me with an x minus 1. And set that equal to 0 because that's the definition of finding our x-intercept, right? So then now we can factor out that x minus 1. We get x minus 1, and then we get x squared minus 9 equals 0. And we have the difference of two squares right there, so we can go ahead and factor that into plus 3, x minus 3. And so your three solutions are 1, negative 3, and positive 3. Okay? And they all have powers of 1. Okay? Which means that they are all going to cross. So those all cross. So, oops, not negative, positive 1. All right, so 1, negative 3, positive 3. And then we don't have any that just kind of touch and turn around. We'll talk about that later when we run into that. But basically, if the exponent on your factor is odd, then you're going to cross. If it's even, then it touches and turns around. And like I said, we'll run into some of that later, and we'll discuss it then. Y-intercept's real simple because if you plug in f of 0, you're going to result in that constant of a 9. So you end up getting that 9 right there on that equation. Okay, so let's plot what we know. Okay, we know we cross at negative 3, positive 1, and positive 3. Okay, and we know we have a y-intercept up here at 9, so it's going by 2. So 2, 4, 6, 8. Sometimes I give you a graph to go with it. Sometimes I don't, and you have to make your own. Typically, it makes it a little bit easier for me to grade if I just give you the graph ahead of time. So that will probably be the case on the exam, and just it'll make things easier for everybody. Okay. So looking at what I've got so far, I know that I've got some x-intercepts. It's going to cross through it each time it crosses. But what I do know is that to the left, it's going to go down eventually. So once I cross the last x-intercept on the left side, I'm not going to twist back up, okay? I'm just going to keep going down. So I'm just going to go ahead and draw that going down. And then on the right side, I know that I'm eventually just going to take off and go up. My graph is just going to go up. So once I cross that last x-intercept on the right side, I know that I'm just going to go up. So I'm just going to kind of just draw it kind of like that. Now I have to figure out what happens in between all my intercepts. Well, I already know what happens at, when x is 0, but I need to figure out what happens when x is -1 or -2. Okay. So I'm going to scroll down a little bit because I'm going to need some space to do this. Now, there's a couple of different ways you could do this. On this particular problem, it might be easy actually to plug it into the factored form to figure out these values. So see this right here, this is the factored form. This is equivalent to the original equation up here. So if I want to figure out, f of -2 equals, so instead of having to do -2 to the third power minus -2 squared and so on, you can do that if you want. But what I could do is just kind of plug it into the factors and then multiply them together. And that would actually probably make the process much faster. So if I plug in -2, the first factor would be -3. The second one would be a +1. And the last one would be a -5. And so if you multiply that all together, that would give us a +15. So at -2, I'm up at 15, which is right there at the top of my screen. So there we go. I think I can fit it now. So let's see it. 12, 14, 15, about right there. Okay, so it's right there. Okay. Now let's go ahead and find f of -1. So let's see, f of -1. So once again, I'm going to plug it into these factors. So if I plug it in here, I'm going to get a -2 times a +2, and then times a -4. And if I multiply that all together, I believe that's -6 or +16, positive plus there. So +16. That's going to be +16. So just slightly a little bit higher. So right there on my graph, right there. Okay. So I have a pretty good idea how this kind of loops up and comes back down, but then I need to figure out how far down do I dip at -2. So now we want to plug in f of -2. Once again, I'm going to plug it into the factors. So let's see, that first factor would give me a -3. Second factor would give me a +1. And the last factor would give me a, oh wait, I'm plugging in +2. I'm sorry. Sorry. Started thinking I was having deja vu, and I was. Okay. So let me fix that. So we're plugging in +2. My bad. My apologies. Okay, so let's see. I get a 1, and then a +5, and then a -1. Double check that. That looks right this time. Okay, so the product of that is -5. So I'm going to dip down here at 2, 4, 5 would be about right there. All right, so I'm going to go ahead and finish drawing this. So let's see, curving up. Kind of peak right around here, start to come back down. Oops. Come down here, kind of do a curve shape, try to make it curve, try not to do sharp turns, just do the best you can. All right, so that's our first one there. Okay, and so we're going to do 4 of them, and I'll tell you right now, you'll have 2 of them on the exam. You just don't know which 2 you're going to have. I mean, it won't be the exact same, but it'll be kind of like the same type of factoring or whatever, same kind of similar shape, graph type stuff. Okay, so there's one of them. Okay, so this next one, to be honest, that first one's probably the one that's got the most work you have to do to graph it. These other ones go a little bit faster. Factoring, basically the factoring is a little bit easier. Okay, so if we want to look at in behavior first, as x goes to infinity, so what's going on here is you've got -x to the third plus 4x. So that negative actually doesn't apply until after you cube it. So you cube infinity, you get a positive number, but then you're multiplying it by -1 in front. So that's going to go to negative infinity. And then when you plug in negative infinity, what happens there is you do get negative infinity in return, but then it gets multiplied by the -1. So this actually flips back to being positive infinity. Okay, so you plug in a negative to the third, it's negative. But then it gets multiplied by -1, so it goes back to being your positive right there. So x-intercepts, we set that equal to 0 and factor. So I'm going to factor out a negative x. And that will leave me with x squared minus 4 equals 0, right? Okay. And I have the difference of two squares again. So I'm going to have negative x times x plus 2, x minus 2 equals 0. And so my solutions here are 0, -2, +2. And once again, you'll notice that all my factors are odd again, okay? And so they're all going to cross. So 0, -2, +2, they all cross. Don't have any that touch. So we'll probably see some of those on the next slide. Y-intercept's pretty easy because if you plug in 0, you're going to get 0 plus that's 1 my x-intercept, so it automatically makes it the y-intercept, okay? So we want to make a couple notes on our graph. One of the notes is as I go to the right, I'm going to go down. As I go to the left, I'm going to go up. So that's kind of how my graphs are going to end. In the middle, I have my intercept at -2. 0, and then +2. So I know that when I go through my last x-intercept on the right, it's going to go down. On my last x-intercept on the left, I'm going to be going up. So now it's just a matter of figuring out how low and how high I go between the intercepts. Now, if you notice this, great. If you don't, it's okay, but this is an odd function, okay? And so what that means is basically whatever I plug in for x, I'll get the opposite when I plug in negative x. So whatever you plug in for x, you're going to get the opposite of what you plug in for negative x. And I'll just go ahead and plug them both in so you can see, but you'll notice that the results are just going to be opposite of each other. You can plug it into the original, or if you want to plug it into the factored form, doesn't really make a difference. This one's really not as messy as the one above. So let's see if I'm going to plug in f of -1. I guess I'll plug it into the factored form like I did up on the previous one. So you're going to end up getting -1 times 1 times -3. So all I did was I just plugged in my x value for all those three parts of each factor. Now, if you multiply this together, let's see, you'll get a +1 here. And you still have 1, and then you have times -3. So if you multiply that all together, it's just -3. Now, since it's an odd function, I can tell you right now that when I plug in 1, I'm going to get +3. But I'll go ahead and plug it in so we can see it. So let's see if I plug in f of +1, I get -(1). That negative is part of the factor there. Then 1 plus 2 is 3. And then 1 take away 2 is -1. So when you multiply this together, you end up getting -3 times -1, which then eventually takes you back to +3. So we're going to be right there. Okay, so let's try to do it with a curve, right? Curves, and then comes up through here, curves, and there you go. That's it for that, okay? So I got two more for us to look at. We'll probably run into some where they touch now. So let's see. All right, very similar to the last problem, actually, very similar. Real quick, in behavior, you're in raised to the 4th power, so if you plug in a positive, you get a positive. You plug in a negative, it actually goes back to being positive because when you put a negative to the 4th power, it will go back to being positive. Okay, so very similar to the last one, except this time I factor out an x squared. I'm left with x squared minus 4, the difference of two squares again. So very similar. So I'll go ahead and factor that. So I get x squared times x plus 2 minus 2. So my solutions to this are 0, -2, and +2. Now this time I had a multiplicity of 2 on that 0, so that one's actually going to touch and turn around. So we'll get to see one like that here. My other two intercepts were -2 and +2. Y-intercept, 0, 0. Okay, so once again, we'll just kind of go ahead and plot our stuff and get started. So let's see, -2, 0, +2. We're going to go up in both directions. So if you want to go ahead and start to kind of draw that, that's fine. So what's going to happen is I'm going to dip down, then touch at 0, and then dip that back down, and then go up through my x-intercept at 2. Now when I hit 0, okay, it's a parabola shape. So I'm gonna make sure I want to make it kind of curve when it kind of comes up and hits there. Also, just a little note, if you notice it, great. This is an even function, which means whatever I get for -1, it will be the same for +1. Because whether you plug in a -1 or +1, when you square it, it's going to give you the same results, okay? So let's go ahead and try this. So let's do f of +1. And you can plug it into the factored form, or the one up here is pretty simple. So I'll just go ahead and plug it in there. So I'm ended up getting 1 take away 4, which is -3. And that will be the result for f of -1 also. F of -1 is also going to turn out to be -3. Go ahead and plot that down here. Okay. So actually, let's do it in a different color so you can see it a little bit better, because I'm going to draw the line green. Okay. So this is going to be a little tricky. So we want to curve, but then we want to curve again. And curve. It's almost kind of like a W, but you just kind of want to curve. You don't want to have sharp points, though, okay? All right. One to go. One to go. Here we go. Oops. All right. So looking at the end behavior here, you have a negative in front. So when you raise it to the 4th power, it's positive, but then you multiply by a negative, so it's going to be negative infinity. When you plug in negative infinity to the 4th power, it actually does become positive, but then there's that negative, so it goes back to being negative. So we're going to be going down to left and right on our graph when we graph this. Okay, so let's go ahead and find our x-intercept. So I'm going to start by factoring out a negative x squared, and that's going to leave us with x squared minus 6x plus 9 equals 0. Now what you're going to notice is you actually end up with a perfect square trinomial here. And so what that does is you're going to get x minus 3, or we can just write it as x minus 3 squared. So our solutions here are 0 and 3, okay? And this time they both have a multiplicity of 2, so they're both going to touch and turn around. This time we're actually not going to have any that cross through, okay? And then the y-intercept, if you plug in 0, causes all that to 0 out, and you get a 0 there. All right. So let's see, got one here at 0, got one here at 3. We know we're going down both ways. So, and it's going to kind of be parabola shaped through both of those intercepts. You can kind of, when you graph the end behavior, you can kind of curve it a little bit, because both of these are going to be parabola shaped when they hit the x-axis there. Okay, they're both going to be parabola shaped. It's going to be parabola shaped. It's going to dip down and come back up. Okay, so we need to plug in 1 and 2. And Once again, it'll probably be a little bit easier to plug it into the factored form to evaluate it. So we'll do f of 1. That would be equal to negative 1 squared times, let's see, 1 minus 3 is negative 2. We're going to square it. So let's see. We end up getting negative 1 times 4, which gives us negative 4. So you get a negative 4 whenever you plug in 1 to this. I plugged it into the factored form right there. Let's see. Let's see, switch colors on that. So negative 4 right down. Oops, whatever. Okay, so now let's do f of 2. Let's see what we get for f of 2. So you'll have negative, and then you do the 2 squared. And then 2 take away 3 is negative 1. So you get negative 1 squared. So you end up getting negative 4 times 1. You actually get a negative 4 again. Okay? Actually get negative 4 again. Okay, now when we graph this, though, it's not like you want to just cut straight over and make a line. It obviously is going to dip a little bit further down, okay? So when we draw this, so we're going to dip down and then kind of dip through there and then come right back up like that, okay? So they both happen to be negative 4, but, you know, it's not like it just all of a sudden becomes a straight line. The whole definition of these polynomials is that they're curved, okay, that they don't have sharp turns. So you still want to kind of curve through there, okay? You could plug in 1.5 if you really wanted to, but I'm not going to be that picky, okay? All right, so that does it for our graphing our higher ordered polynomials.